Good afternoon, and thank you all for coming. It's great to have the room filled like this. So, for those of you that I haven't met, I'm Tony Giannidis. I'm the director of the Pardee Center for the Study of the Longer Range Future. Let me tell you just a little bit about the center before I introduce this afternoon's speakers. So the center is really put together in order to catalyze research across the BU campus and more broadly, structured really around the idea of understanding better the forces that cause the world to evolve the way it does. Those include political forces, economic forces, environmental issues, and health issues, and a whole host of issues that are important in both the developing and the developed world. And we have really tried to look further than simply diagnosing challenges, to moving towards the research that's needed to provide the foundation for actual solutions. So with that, I'm really very pleased to introduce this afternoon's presentation and then discussion. The topic here is one of the, in a sense, underserved topics in climate change research, and that's the looking at and trying to understand the potential impacts or current impacts of change in the physical climate system's effects on human health. There's been a lot of, recently there's been a lot of discussion of this, but the actual empirical understanding of these impacts is really still rather thin, and particularly so for impacts in the developing world. And so this is really a very both challenging and very important topic. Our speakers today are all Pardee faculty fellows. Professor Susie Foster is in the School of Public Health, Professor Gopal in Earth and Environment, and Professor Bruce Anderson also in Earth and Environment. And so since you didn't come to listen to me talk, but to listen to them talk, I'm gonna hand this over to Susie. We'll start.
Okay.
Oh, can I say one thing? Next week, this is the first of a series of events. We have quite a busy April. Sorry, Susie, I forgot to mention this. So on Monday, we're having our distinguished lecture, Monday afternoon, in the trustees ballroom. We have Professor Bob Watson coming. So Bob has chaired about every international scientific assessment that's ever been done. He's chaired IPCC, both the Working Group 2 on Impacts and Adaptation and the entire IPCC. He's chaired the Millennium Ecosystem Assessment, the Global Biodiversity Assessment, and a wide variety of other things, and has held leadership positions everywhere from NASA to the World Bank to DFID, the UK's development agency. And so we're really I'm very pleased, and I think we're extraordinarily lucky to have Bob coming to campus next week. So please take this opportunity to hear one of the truly global leaders in this interface of science and policy come to BU and share his thoughts. So I apologize. So now I will do what I said I would do, which is hand this over.
Okay. Well, thanks very much. So we have put our slides together, and I'm kind of got some introductory slides. And here's kind of a graphic that sets it out, some introduction, and then some more on the impacts, some more on sort of meta-analysis of some data, and then finally focusing on El Nino and the impact on heat and heat strokes and so on. So some of the key trends that we're going to be talking about today would be changes in disease patterns, changes in vector-borne diseases, habitats of different vectors, particularly the malaria mosquitoes, but also the Aedes mosquitoes, which are responsible for Zika, among others, Zika, dengue, some other key diseases. And Professor Gopal will be elaborating on that a little bit more. Changes in the availability of foods and the prices of those foods are coming down the road, and particularly wheat, rice, and maize or corn. And as you probably know, a very large fraction of the world's population lives on those three staple foods. And those are going to have difficulties adapting to a warmer climate. And we'll hear more on that as we go on. I'm also going to focus in my few minutes, not so few, but anyway, on the issue of population displacement, because we're already seeing a lot of displacement of large numbers of people due largely to flood, but also in some places due to drought, due to the drying up of lakes and so on. And this is a trend that I think has not yet been adequately focused on by people in positions of authority. We had the visit of the Indian Minister for the Environment a few months ago, and we were chatting with him, and I said, well, have you thought about, or what are the plans for population displacement in India? And he kind of said, oh, no, not a problem. And I thought, really, not a problem? And it's just that his attention is turned elsewhere. But it does seem to be happening. I'll show you some information on that later. So, and with that come all kinds of things, including increasing landless populations. People lose their access to land because it's continually flooded or it becomes salinated because of seawater incursion and so on. So they have to move to some other place or find some crop that will grow in that particular area. So this is potentially a large impact. Some of these public health impacts that we're going to be seeing are, for example, the impact of heat, and we'll be definitely hearing a lot about that. We'll talk a little bit about flood and drought and the consequences that come from those, particularly morbidity and mortality directly related to the heat, but then also the spin-off effects on different diseases. The impact on malnutrition and basically on food availability and food prices. As we know, supply and demand, as soon as availability goes down, then prices go up. And already we have a large part of the world, especially the world's poor, spending well over half their disposable income on food already. And if prices go up, that will be really, really a big burden for them. Displacement due to flood and drought, as I mentioned, loss of land, moving to places where they have no rights over the land, and that leads to conflict with the people who are already there, and then thus more poverty. And we have this, I don't know if you've run into the concept of entitlement. This was from Jean Drèze and Amartya Sen. They noticed that famines happen often where there is food, but the problem is that the people, particularly poor people, have lost their what they termed entitlement to buy that food, because their land is flooded and they have no crop to sell, or for whatever other reason. The food is there, the price has gone up, but they have lost the ability to buy that food, to command any access to that. And then changes in food availability and water. I'm not going to talk much about water availability and cost and quality. That is a whole nother seminar, but we should not forget that water is going to be a major issue. This is a slide that is kind of interesting, especially because this shows the global vulnerability. Standard & Poor's is the source of this. So the financial community is paying attention to this. And you'll see that in this particular map, the U.S. is all in green. Oh, no impact. But we'll see later on that actually there are some things happening. But there's a large amount of red there in South and Southeast Asia, and then in a couple of countries of Africa. And so remember where that red is in South Asia. And then remember that, you've probably seen this map before, half the world's population lives in that area that is colored red on the vulnerability map. So that is, and that's the area we're going to be talking about more in today's session, focusing particularly on India. But that is a very vulnerable area, and it's also where a preponderance of the world's population is currently living. So we definitely need to be spending some time thinking about that. This is a map from the World Bank about the projected impact on agricultural yield. And you can guess that red is bad. Green is good, and you can see that there are a lot of countries and areas colored in red. And again, we see a lot of red in South Asia and Southeast Asia, where that circle was, where the majority of the population. We also see a lot of red in Northeast Brazil, and in parts of Australia and a few other places. And you see generally the greener is moving further north. If time permits, I'll show you a map of where they project wheat will be able to be grown in as time goes by here in North America. It's quite interesting. One of my last slides. So one of the things I think we need to really think about is the impact of this climate change and these different ways that it's going to be playing out on poverty. And the World Bank is paying attention. They're another group that's definitely paying attention. They've produced a number of really interesting reports I can recommend that if you're interested in this subject, go to their climate change pages. This is a quote from a thing that was issued in November 2015, so just a few months ago, that poor people are already at high risk from climate-related shocks, including crop failures from reduced rainfall, spikes in food prices, again, then they can't afford the food, and increased incidence of diseases after heat waves and floods. And then they suggest that without rapid, inclusive, and climate smart, they have this term climate smart development. It's interesting because I think I was at the World Bank quite a while ago now. This was totally not on our agenda, not there at all. And finally, it is on the agenda at the World Bank, so that's a good thing. Whether they're doing enough, that's a whole nother matter, but we'll see about that. So they're talking about climate smart development and with emission reductions, which largely is our job. My little car parked outside. Oops. It is just a little car though, but still, I did drive. That they're projecting 100 million additional poor people in poverty. And when they talk poverty, they're talking like $1.25 a day, severe poverty. By 2030, particularly in Africa and South Asia. Now 2030 is not that far off. It's not that far off. I expect I'm even still going to be around in 2030. I'll be a little creaky, but I think I'll be here. So this is from the World Bank graphic that they put out to accompany that report. They're focusing on three main areas: on natural disasters, and that poor people are obviously much less able to recover from a disaster. They're on the edge at the beginning, and when a disaster comes, wipes out their house or floods their fields, they're really or their one cooking pot floats away down the river. There's not a backup. There's no resources behind them to deal with that. The next one is agriculture, and the majority of the world's poor, actually, is this still true? Probably not. I was going to say the majority of the world's poor are rural farmers, and I am not sure that's still true. I think it might be that the majority are actually urban dwellers, but maybe 50-50 or 40-45, 55, somewhere in there. But these crop yield losses that they're projecting are going to have a major impact on prices and just on plain availability of food. And it's also apparently going to change the makeup of the food. I read an article not too long ago about how fruits were going to be particularly affected and become harder to grow in a lot of climates. So, and some nuts will be affected too. Nuts are a bit sensitive to climate as well. So just the mix of what is available may change, and the price will go up of those desirable things like fruit. You might not get a bag of oranges for $4.99 or whatever it is at Stop and Shop. And then the health impacts. When we see just 2 to 3 degree rise, we're definitely going to see a rise in the number of people at risk for malaria particularly, but we're also worried about other diseases. And Professor Gopal will go into a bit more detail on some of those. So the World Bank's prescription for this is this climate smart development. They're focusing on these 4 things, and I'm a little bit, these are nice things: social protection and health coverage, early warning systems. Okay, warning, but what are you going to do? You've got the warning. What is the answer to that piece of information? And then climate-resistant crops. Definitely, I think that's one way to go. But is that enough? Their report called Shockwaves, which came out in November, these graphics came out to accompany that. Actually, this is recapitulating what those other messages were. But one other thing that they're mentioning here is the thing that Professor Anderson is going to talk about, and that's the labor productivity of the impact of heat. You know, if it's almost too hot to live, it's definitely too hot to go out and farm. And you know, how are people going to farm by moonlight? Are they going to bring lighting into the field so they can work at night? You know, what's actually going to happen there? So those are some of the strongest drivers of this. The food price impacts could be quite significant. They're talking about 12% by 2030, but as much as 70% by 2080. That's a ways away. But looking around, some of you are going to be here. You'll be here in 2080. I definitely won't be here in 2080. That's for sure, unless some major discovery happens, which I'm not expecting. But as I mentioned, where people are already spending 60% of their disposable income on food, that's just going to lead to massive undernutrition for sure. So they're proposing to improve resilience of the poorest people by strengthening their social safety nets and providing universal health coverage. But where's the money going to come from to do this? You know, this is kind of something we've been trying to do for many, many years in the health realm, and we've made a few inroads, but not dramatic inroads. I mean, look how hard it's been to get universal health coverage here in the U.S., where we have, you know, we spend more on health than any other country in the world by far, and we still don't manage to cover everybody. There's a whole bunch of reasons why that is, but it's not just something you can wave your magic wand and have it happen. And then some climate-specific measures could be implemented. Upgraded flood defenses. Cyclone shelters have been implemented, particularly in Bangladesh, which is very prone to cyclones. Early warning systems so people know to get to the shelter. There needs to be, kind of interesting little side note, in preparing for another class I teach, I looked at a case study of the cyclone shelters. And one of the problems was, Bangladesh being a very conservative society, women felt that if their husband wasn't there to tell them it was okay to leave the house and go to the shelter, they stayed at home with the kids and drowned. So it's not just build a shelter and everything's hunky-dory. There's a whole lot of other things that have to go on in order to make that an effective response. And then the climate-resistant crops. Now, most of the displacement that we're seeing is due to floods. And I know you can't read the small writing on this, but I'll just tell you that of all these little bubbles, the only one that is not floods, if I'm not mistaken, is the earthquake in Yunnan, which was in China. I think it's the second from the bottom little button on there on that bubble. The rest of these are all floods. The displacement, and the total number of people displaced is 32 million. This is 2012. Now that's doesn't maybe sound like a lot of people in the grand scheme of, you know, percentage of the world's population, but it is a lot of people displaced, and some of them are not going to be able to return home anytime soon. So you can just see from this map that it is very widespread. It's every continent has had some, but predominantly inside that circle of the half of the world's population in South and Southeast Asia. And also, this is just again to notice where this map came from. I don't know if you can read. No, you definitely can't read it. From a thing called Business Insider. So again, business is paying attention to this. Okay, 5 minutes. So where are people going to go when they're displaced? Are they going to go to other rural areas? And what will happen when they are displaced to other rural areas? Will they get access to land? That is especially in a place that's already very densely populated. Land, ownership of land is very, very fraught with all kinds of issues, but it's just not something you just move on and start farming. Someone is already there. And will their knowledge transfer? Will their knowledge about how to farm in this area transfer to the new area? Will they be accepted and welcomed, or will conflict erupt? And there's a lot of indications that conflict is likely to erupt. If they go to urban areas, what skills will they bring? How will they survive? How will the cities cope with the influx of migrants, new migrants? There is also this link with climate and conflict. And the example that I found online relevant to today's talk is about the region of Assam in northeast India, where Bangladeshi migrants are moving to escape flooding and problems with salinization of their lands and their rice fields. And also they're moving for some construction jobs. And there have already been clashes between the local Bodo peoples and the immigrants who are Muslims from Bangladesh who are not particularly welcome. There's also been flooding in that area from the river that flows through, and so it's been an area of a lot of change. This is a map that shows migrations within India, and this is a map from a security site run by the Wilson Center, and you can see obviously the big red arrows is population movements, and the gray color is the climate change areas. So a lot of this movement you can see is already from areas that have climate change issues and people are moving. You can see too, they're a little bit harder to see, the dotted lines moving from Bangladesh up into the Assam and the other northeast parts of India. And so that's partly where this conflict is coming from. This is a map. Okay, that was the end of the slides.
What was the last map?
The last, there was this one. It's nothing. And then the wheat map isn't there, so. So I will
Well,
move on to
If
Professor Gopal.
people are interested in the presentation, I think Cynthia is going to put that out. So the entire PowerPoint slide set is more than 75 to 80 slides, and we've hidden away most of the slides. So if you want, please let us know. We'll share it with you. So I'm going to get started with just looking at India, and I'm going to sort of give a feast for your eyes because it's going to be a lot of maps and a lot of pictures. I figured since it's like a lot of data to present, it's much easier to show you by way of maps and colors because there's no time to go into details. So I'm probably going to spend some time looking at just the health statistics. You all know that India is going to be the most populated country in the world in the next 5 years. It's going to overtake China's population. You can look at the population growth. The growth of population in India is not as high as some of the other countries which have a higher population growth like Mexico and some countries in Africa. But given the fact that it is a big base, this is pretty serious, as Susie was pointing out. I can also give you statistics on life expectancy at birth and also the healthy life expectancy ratio, which is 57.5, which means that the averages don't always add up for the poor especially. And you can also look at the probability of dying between the age of 15 to 60, and most of these statistics don't reflect climate change at all. And as Susie was pointing out, a lot is now resting with climate change. We don't recognize it directly as a consequence of climate change, but it is happening. So that's just to give you some background. So we can also see that this was actually the Ministry of Environment that put out this notice about climate change in India and what they are sort of seeing. The glaciers in Himalayas receding is something with a star because there is no real scientific concrete sort of evidence. There are a number of suggestive studies, but you could probably look through this and see it looks like pretty serious. And we already saw maps of floods in India, maps of droughts in India, and people moving on a massive scale and so on. I think the last time a huge section of 1 million or so people moved was during the partition. And we are seeing something like it happening all over the country. So the next slide is, I wanted to point out to you, if anybody is interested in this topic, the Lancet at the end of 2015, and Tony, I think you read the Lancet, they put forth an article on climate change and health. And this is one of the most seminal articles that was ever written seriously about this subject, and it's pretty recent and updated. And they talked about a whole bunch of issues all across the world. And the interesting thing to notice here is there is the natural environment, which is shown to you in red, which is floods and droughts and all the direct consequences of climate change. And that sort of goes hand in hand with the socioeconomics. And poverty and the poor is what Susie was talking about. And that combined produces a whole bunch of issues in India. So there's regional disparities, there's lack of access, lack of education. Doctors don't know the difference between, in some of the places, they don't know the difference between dengue and how to treat chikungunya. They misdiagnose. So there's a lot that is happening in terms of empowering people with the right knowledge, and maybe that's why the World Bank thinks it's good to build all kinds of apps. But, we got to wait and see. So I wanted to sort of take you more directly into changes on health in India. We want to look both at the direct effects as well as the indirect effects and the vector-borne diseases. So a lot of literature is paid a lot of attention to vector-borne diseases, malaria, dengue, and so on. So you find diarrheal diseases for the young, for the infants, was always there in India. And now it's on the rise because of the quality of water that Susie was talking about. And we don't actually count and say these are the number of people who died as a consequence of water reflective of climate change. So it's not being counted right. And if you put all these things together, the implications for India is huge. And I hate to use the word huge now, but you know what I'm saying. So the next slide going in shows the demographics of India. And you can see this is the population density. And the red, of course, indicates the very high population density. That's unfortunately, I can't show you. The red up north is the Ganges. And you can see these are the rice producing, these are the wheat producing states in India. Uttar Pradesh is one of the most densely populated. You can also see that the population down south in the peninsular part of India, which covers 3 different states, it's also pretty high. And sections towards Gujarat and Maharashtra are also pretty high, and that's marked on the state map on the left panel. Keep that in mind. So this shows you the flood map. So I'm going to actually have a quiz at the end of the show because I'm showing you lots of maps. I'm going to ask you what's the most dangerous climate vulnerability region in India, because I'm showing you a series of maps. So just keep that in mind. So I showed you the density, now I'm showing you the flood maps. And I think Susie talked a little bit about floods. Floods are a big problem in India, no doubt about it. And you can see that all of the major rivers in India, including the southern rivers, do have floods at most times. And many people have gone in and said, what were the worst floods in India? And there's a lot of statistics on how many people died and what was the storm and who was affected and so on and so forth. And I'm happy to share that with you. At the bottom of every slide, I sourced all the information so you can see it. So this one shows dengue in India. So on the on my right axis, I'm showing you the deaths, and on the other side, I'm showing you the incidence. And you can see that it has steadily sort of increased. 2014, they got a little bit of a break, and 2015, it's back up being high. And dengue sort of is pretty significant in many parts of those flooded zones that we saw where the vector-borne infection is high. And it also coincides very well with the malaria map. So that's why there's a frequent misdiagnosis of malaria and dengue too. And it's again mosquito-borne disease.
So, Suchi, are those absolute numbers or deaths per million?
So I have all the counts. The ones that I showed you are absolute numbers. And this again is a question mark because I believe that there is a bias in reporting. They may also be, the counting may be wrong because these are the officially produced statistics. And there I have incidents by sex and by age and things like that. I make a note of it. So this shows malaria over the period of time for India, and it shows falciparum cases, deaths, and incidents. And you can see it's pretty choppy in terms of history, and India plans to control malaria by the year 2030. This is the ministerial report which promises that it would be under control in 2030. But given the distribution that you see right now, and given the fact that they have climate change, it's kind of questionable because all of the information and whatever they want to do by way of public health outreach has to reach at a local scale. And Susie can talk a little bit more about it. Oh, this is the one that Tony, you were asking about. So this is the exact thing in terms of accounting for the incidence according to age and gender. And if you look at it, the gray areas that I'm showing you are the unstable malaria transmission areas, which means they may not get malaria this year, but they are unstable and it's impossible to predict what's going to happen to them. And there's also all kinds of other things that they have taken into account, including people who have some kind of resistant gene. That's the Duffy negative that I've put in. And I gave you notes at the bottom if you want to read about it. So it's important to keep this map in mind. You can see the entire India is covered more or less by one thing or the other in terms of malaria. So these two maps show the temperature, the conducive conditions to malaria, I believe. And there's so many different ways of slicing and dicing this data to understand and make predictions of malaria. So there's a lot of information coming from remote sensing. So all of the studies sort of focus on this. Where the data is very strong is the climate data that's coming from NOAA or NASA or some other place, and Bruce is going to talk about it. And where the data has to come on the incidence, not much is available. So that's the mismatch. So malaria in India, these are all official figures. So I'm only giving you what the government releases by way of numbers. So you can see that particular years they had more incidents, and in general it looks like there is a lot of deaths due to malaria, and this is reporting all over India. But I do believe there's an undercount because many deaths don't get reported as being due to malaria. So the other thing that's happening all over India, especially in the south, is chikungunya. How many know what this is? This is also mosquito-borne. Tony, you want to tell us how you...
It's another vector-borne fever disease. And
Right.
It's hard to diagnose.
It's very hard to diagnose. And many women who get it don't, it's all these cultural factors that Susie was again talking about. They don't know. And they think it is like, it'll go away after a few days, and it doesn't. It gives a lot of pains and chills, and it's frequently confused with malaria. And so they take malaria drugs for that, which is the wrong thing. So that's the map of India that shows this through the time period. And you can see that it's on and off, but the south seems to have a lot more incidence of chikungunya than any other place. And this is different from the malaria map we saw before, because that was spread more towards the north and towards the Ganges.
Different vectors, too.
Yes.
Is chikungunya introduced? Is it recent in India?
It started being diagnosed as of the 2000 period and later. And more attention has been paid from 2011, I believe.
Right, because most of what I've read about it has been in Latin America and the Caribbean.
Right. And so this, I think, is very important for India because diarrheal disease is what kills young infants and people under the age of 5, children under the age of 5. And so you can see that they know about it, and yet, there's a lot more that can be done, sanitation campaigns, sewage treatment facilities, and so on and so forth. And India has a grand plan for doing this, and they talk about it all the time. In 2008, they put forth a report. The Prime Minister put forth a report, and he emphasizes all the things that are going to be done, and things are turning around. A lot more sanitation is being handled, and more public attention is being paid, and sanitation and sewage companies in some ways are getting more and more responsible because of public outcry. So moving on, I wanted to talk a little bit about air pollution, and you keep this in mind because I'm going to show you Google searches. The number one searched item in India on any kind of environmental health is air pollution around Delhi, the capital city. It's like in the millions. So they now have a little app which shows you where exactly is air pollution. They have a website. All the cities in India, there's 60 cities which have like exceedingly high air pollution. And I don't have that map there, but I'm showing you all the air pollution remotely sensed imagery and showing you the connection to air pollution. But there's a lot of information that's available because this is a pretty serious problem in urban India. And it affects a lot of things by way of health, and you all know about it. It's not just asthma and, dry eyes or, tears in the eyes, it's a lot of other things. And so there are a few very nice sites that show you what's the cause of air pollution in different cities. And people are thinking about it, and people are talking about it, and obviously air quality is very important. And now the new ministerial plan in 2008 that I pointed out talks about emission control, turning into hybrid cars or electric cars and so on. So we'll come to that. And I just wanted to say, in order to do anything in India, you need to collect a lot of data. We do have the climate data and demographic data to some extent, but we don't have very good data coming about the exact incidence of the disease or the deaths. And we can identify, using all this, we can identify vulnerable regions and populations. We can build a knowledge base and sort of empower and educate citizens. And as Susie was pointing out, very important to carry this information to the community and somehow to educate them, to drink better water. There were studies in Bangladesh which kind of show which well is, clean enough to drink and which well is not. There are a lot of things that one can do to talk about risk and consequences of, climate change in India. So in terms of public health perspectives, I'm going to let Susie talk about it, and we can sort of come back to this if you have questions. And I want to move over to the third part, which is the meta-analysis that all of us are doing as part of our research. So all three of us looked at this in the last summer with a student, Michelle, who's graduated, and we looked at how many things are there in terms of searches made for India climate change and health, how many such searches were made on Google Scholar using, just the word health. And you can notice health is more predominant in terms of a search than this. So if you look at the Google Scholar search and see what the trend is over time, a lot of information and publications are happening only after 2005, that period on. And very little awareness of climate change and health connection before that, particularly in relation to India. And so we've looked at all the topics and we've sort of thought about how to write it. And I think, Bruce, you suggested this. We need to look at PubMed separately. And PubMed has fewer collection of articles on India specifically. And of course, the CDC and PubMed publish a lot of things on climate change and health, and they make all this available. All of these are open source articles for most part. The one thing I wanted to point out to the people who are like Googlers is this one on Google search trends. Google has taken climate change very seriously, and they give you this on a daily basis. They tell you exactly who's searching for climate change and what aspect of climate change, because they build an entire ontology of climate change. It's really fascinating. You should go see it because it's dynamic, it's beautiful. And this one shows the searches that I was telling you about of what's happening in India. And you can see that the major cities, there's a lot of search, and the states which probably experience a lot of things in terms of climate change are searching more for climate change as a word in relation with health. But as I told you, air pollution, the most highly searched term is from Delhi. Very interesting to find behavior of what they're searching for. This is just a contrast with the United States. And I'll ask you why people are searching this way in the US. So Alaska is very dominant for climate change searches. So moving on. So in the end, we came to conclude that all studies could be positioned this way. We could look at health effects, we could look at air pollution and environmental effects, and we could really understand how this meta-analysis of climate is being laid out. And this is where our next research effort will be focused on in the summer. We are going to write this article up looking at more than 2,000 articles published in this topic area. And I just am mentioning broad themes. You can find that there is a lot of information on land cover changes, deforestation, salination, urbanization, and so on. A lot of information on food security, poverty. That's one of the major focus of most of the major articles. And I'm looking at the doctoral students, and you all know what I'm talking about. And there's many papers, in the medical journals are not so sort of specific. They're very, very specific in terms of local and regional scale. Maybe they don't mention the word climate change. They mention all the diseases. And the major problem is collecting data in a country like India. I could get the climate data, but I don't have access to the incidence data. So that's the major problem that we have. And Bruce will explain what we did with the heat strokes. And you'll see what he's going to tell us. There's a lot of things that the Prime Minister and the policy makers in India have put forth. And these are some of the things that we would say, and these are some of the things that they are echoing. That you really need to make sure that you reduce the vulnerability of the poor. You need to implement mitigation, adaptation strategies and actions and policy. You really need to make all this knowledge and resources available at various regional scales. And I think it has to be introduced into education at all the colleges and schools in India, so somebody else can take and march with it. So there's a lot of work that needs to be done on the topic of climate change. So Bruce, it's you.
Oh, thank you. So in the last two talks, we've had sort of a brief brief. Much too brief, actually. We probably could each give an hour-long talk on this. An overview of the impacts of climate change on health, and then also health issues in India. And so now what I'm going to do is take a deep dive on one very particular health-related issue, namely at the nexus of climate and heat strokes. Well, it's actually heat mortality. And so I'll give you some just background, I'll just give you the results of this presentation, but recognizing this is just one of many, 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 many studies that could be done in this region on this topic. So this was done with Suchi as well as the student Michelle Gilmore. We were looking at, in particular, a projection of what might happen in this coming year in response to some changes that we've been witnessing in the central equatorial Pacific associated with what we call the El Nino, and I'll get to that in a bit, but you've probably already heard about that. And we're going to look at it in the context of possible additional mortality resulting from the El Nino that transpired this past winter. So, as was mentioned, there is health impact data and there's climate data. Health impact data is sparse. This is our health impact data. Being sparse, it's easy to collect. So you go to their officially documented reports, which are at the bottom. You get tables, and they have a table from 1979 to 2008 of what they consider to be heat-related deaths. There, that is our socioeconomic data. That is what we get from the socioeconomic side. Now we're going to go to the climate side. And wish we had more. Were that we had more, we could parse it out more, but this is what we have to work with. Okay? So most of the effort then was directed at understanding the climate changes that were producing these heat-related deaths. And that's where most of the effort went in. So we went to a very standard set of station-based data that's available around the globe. It's station-based data that's collected daily. In some stations of the world, it's been collected for the last century. For India in particular, we made sure that all the stations that we were collecting this daily data from had data up through the end of the pre-monsoon season in 2015. We also needed some historical record to compare with the mortality data. So indeed, we wanted to make sure that the data went back at least 40 years and that we could, within a given 50-year window, 1966 to 2015, at least have for every single day 30 years worth of data so that we could build both a climatology, which is sort of what the average conditions are like, but also witness some variability about that. And so given those conditions, and the other condition was that we were looking at the pre-monsoon season. Why the pre-monsoon season? The pre-monsoon season is when most of India experiences its heat waves. As we move into the summer season, the heat builds and builds and builds, but as soon as the rains show up, the heat dissipates. The temperatures actually get cooler. So it's the period April through July that are the hottest months in India and when they experience the most heat waves. So those are the 4 months we'll be looking at. Out of all the data that was available to us, 58 stations met the criteria that we wanted to meet. So then we had to go get some metric that would inform our understanding of the heat-induced deaths. And there are many metrics out there. We chose a heat index, which is a combination of the daily temperatures along with the relative humidity, recognizing that relative humidity, as it increases, degrades our ability to remove heat via effectively sweat. We just can't dissipate our internal heat, and it builds up. And so we picked one. It's a very well-regarded one. It's defined and put out by the World Health Organization, at least the equation. It's a nonlinear equation between temperatures and relative humidity, but it's calculatable. And so we did. So for every day, we could get a heat index. Every day, every station for 30-odd years, we could get a heat index. We then wanted to go look specifically at extended periods of elevated heat, namely heat waves. And so then we looked at heat waves, which were defined as any 3 consecutive days in which the heat index exceeded 40 degrees Celsius or 103 degrees Fahrenheit, chosen because that is considered the danger classification by the National Weather Service. So now we have a definition of a heat wave. This last portion here is really what you do with missing data. It's unimportant for right now, but it takes up a lot of space on the slide. You can account for missing data. At some point, you have too much missing data, and you don't want to impose or infer too much about the days that you don't have data for, but we accounted for that. So for all the observed days, we had some mechanism of identifying what the exposure was in the context of this heat index. We could then, on any given day, define what we call the anomalous heat. What was the heat index that day compared to what you might expect on that day? The difference is just the added exposure on that given day. And then, so we can do that for each day, and that represents the additional daily heat experienced above average, but really it's number 2 that we care about, which is the cumulative heat index. For every day we have the anomalous heat index. What's the anomalous or the above average heat that you're exposed to? But what we really care about is over the heat wave periods. And there we just sum up all of the additional exposure for however long that heat wave extended, whether it was 3 days, 5 days, 7 days, and that became our cumulative heat index anomaly. And so it's the additional heat experienced during a particular heat wave at a particular station during a particular year. We have it. The data we use most is number 3. So at a particular station, you can then look at the number of heat waves that occurred at that station during a given year and add all of those, that accumulated heat over the course of the pre-monsoon season. That's sort of the standard metric we're using, so it's number 3. But we can look at other characteristics like how long do heat waves persist, what is the total number of days of exposure to heat waves during a particular year at a particular station, that would be number 5, and then just how frequently do they persist, or how frequently do they occur at a given station. And so the next 2 slides, because for time, I'm just going to, again, go with the visuals. I won't describe everything. Look for big circles that are red. Those are the places that are at risk for elevated exposure to heat waves. So we can, these are all the states that we'll be looking at. The 50-odd stations are all the stations here. Those are the ones that we could use. Some have never experienced a heat wave. Those are the black stations. So of all the 58, 46 actually had heat waves and hence were suitable for analysis. And so those are the locations. And here are some of the summary. Oh, you X'd out my summary statistics. Okay, so never mind. So you don't have to worry about the summary statistics. It'll shorten the talk. Okay, so you can come up with summary statistics. You can come up with sort of what the average conditions are like at a particular station, who's at most risk. Generally, the eastern coastal regions are at most risk. The northern stations are at most risk. The western coastal regions are actually at the least risk. And obviously, the black stations, usually because of elevation, are the least at risk of all because they've never actually experienced a heat wave. Okay. So once you've got the summary statistics, the climatology, you can go and identify how things have changed. Now this next figure is relatively complicated, but what I'm going to show is 2 years, 1998 and 2010. The size of the circles up there indicate the total exposure at that particular location during the accumulated over the whole pre-monsoon season. So that's 1998 here, 2010 here. And so we have these for every year. We can then aggregate these over all of India. So we can come up with an aggregate for the aggregate exposure of all India. And that's what's shown down here. Effectively, if you were to take 1998, all those stations, and stack them, that would be your all aggregate. And it's this very tall bar right there that I can't point to because I can't walk. And so what you can do is aggregate them. And you see right away why we picked 1998. It is the year in our historical record with the greatest overall exposure, okay, to heat. What was the second greatest exposure? 2010. And if you can see the bars, it's the second tallest bar. Again, I can't point to it. And then, if you guys know, last year, 2015, is the last bar on this figure. Does anybody know why we made sure to include 2015?
That huge heat wave in the eastern coast, the state of Andhra Pradesh.
Yes. So 2015, despite the fact that it's not even in the top 5 of overall aggregate exposure, had at least 250,000 additional deaths attributed to heat waves. And in fact, that is the highest mortality due to heat waves across this entire record. So despite not having even in the top 5 exposure, it had the highest incidence of heat wave-induced mortality. That's what got us to start asking questions about how the two were related. There's a few lines drawn on here. The dashed line is the linear trend for the aggregates across all of India, and you can see that indeed there is an increasing trend that explains about half the variability overall from year to year. But absent that trend, you still see very large swings from one year to the next. And you'll see a solid line. The solid line is an indicator of the state of the central and eastern equatorial Pacific. Namely, it's the Niño 3.4 index. It tells you whether in positive conditions, whether the state is warmer than normal, an El Niño, with negative conditions being a state that's cooler than normal, a La Niña. And just so you know, the zero's there. The 0 here is centered on the average of the heat indexes on the other side. That's why it goes from negative to positive there. And what you can see is that both 1998 and 2010 aligned with El Niño years. 1998 being the largest El Niño, or the largest El Niño that we've experienced in this whole historical record. 2010 being the most recent El Niño that we've experienced in this entire record. And in fact, there's a very well-known association between the state of the eastern equatorial Pacific, the El Niño state, during boreal winter, December, January, February, and heat-induced mortality, well, not heat-induced mortality, preponderance of heat waves the following pre-monsoon season, 3 to 4 to 5 months later. So what we have here is precursor information. If we know what the state of the eastern equatorial Pacific is like, we have some mechanism for knowing what the pre-monsoon season might be like with regard to exposure to excess heat. That's the lead time that we can start to act on. We only have about 3 to 4 to 5 months, but we do have 3 to 4 to 5 months, and that's what we were hoping for. And I'll show you why in a second. Okay, so this is the geographic regions, and then this is the all India exposure. Now, as I mentioned, we can actually compare. We know that 2015 had a very high mortality rate. We could compare its geographic heat wave exposure to, for instance, 1998, which we know is the year in which there was the greatest overall exposure. And here's that comparison. The size of the circles here are exactly the same scaling as the size of the circles in the previous figure. The only difference is that the colors also represent some measure. They're equivalent, or they are actually proportional to the size of the circles. They are a measure of the overall exposure during the pre-monsoon season at the given station. Underlying that is shading that represents the population density during the particular year, 1998, as compared with 2015. You'll see that the population density has actually increased in many locations in India in the intervening 25 years, or 20 years. Now, do note, though, we can see just how geographically extensive the exposure was in 1998 compared to 2015. 2015, most of the exposure was confined to the highly populated regions of northeast India and some of the coastal. Well, even those regions experienced heavy or enhanced exposure during 1998, but also you find this exposure up and down the eastern coast of India during 1998 following the monsoon. And we can then ask in the box, is this a function of the intensity of the heat, or is it a function of the duration? And in fact, the y-axis is some measure of how different the heat index was on any given day, and there's not much difference. What really differed between 1998 and 2015 was the duration. In 1998, the duration of heat waves was just twice as long as in 2015. On average, heat waves persisted for about 20 to 25 days almost a month in 1998 as compared to 10 to 15 days in 2015, okay? And it's really just the extent in time, the duration of the exposure that made all the difference in 1998, okay? Now that's just the climatic influence, okay? But we have noted that 2015 was recorded as the year with the greatest incidence of heat-induced mortality. Well, we can go now look at, given the fact that we have this aggregate exposure in India to heat waves, we can look at that aggregate exposure from one year to the next and compare it to the heat-induced mortality from one year to the next, and that's what's shown in the scatter plot here. On this x-axis is just the values you saw in that bar plot. It is the aggregate exposure to heat waves in the pre-monsoon season for any given year, plotted against the heat-induced mortality that we got from the table for that same year. And absent one line, or one dot, there is just a really, really nice linear relationship between those. Great. So we do recognize that, in fact, there is this correspondence between exposure, aggregate heat exposure in India, to heat-induced mortality aggregated over India. Okay. Well, let's add 2015 to that, which is that star up there. 2,500 additional deaths in 2015. But notice, despite the fact that if you did these numbers, the heat exposure in 1998, which is this dot right here, is twice as large as 2015, the heat-induced mortality reported in 1998 is actually less than 2015. This could be a function of two things. It could be a function of the fact that there's an ever-increasing population over that intervening period. It could be, though, that there is just a systematic underrepresentation of the influence of heat on mortality. Okay? They just aren't reporting it as heat-induced mortality. Now, we can't tease out which of those two is most appropriate, but we can look at the overall influence. One way to do that is to take the 2015 heat exposure and compare it to an analog. And that's the blue dot, 2002, it turns out. The heat exposure during those 2 years that were separated by 12 to 13 years, they are within 1%. So they're analogs to one another as far as the climatic conditions, and yet in 2015, the heat-induced mortality was threefold greater than in 2002, which suggests that maybe we can devise a mortality ratio that allows us to scale up all of this either underestimated mortality or potentially just additional mortality due to enhanced population growth. Okay? Well, we could do that for 1998. What would happen in 1998 if we applied this threefold increase? What would the mortality be should the 1998 El Nino hit today? We could do that. It would be academic, you say. Not necessarily. Here are changes in ocean temperatures, where reds are relatively warm, blues are relatively cold. Ocean temperatures in 1997 for the 1997 El Nino on the left-hand side. And on the right-hand side, the 2015 El Nino, i.e. from 3 months ago. Okay? This is the conditions 3 months ago. That's the world beater El Nino that we experienced in 1998. You can see that they're nearly identical. Okay? This one's a bit more extensive in geographic extent. Locally, that one over there has a bit warmer temperatures in the eastern equatorial Pacific. But if you were to measure as a metric some estimate of the state of the equatorial Pacific, the Nino 3.4 index. Here is the time series running from January in the blue line, 1997, to December, which we just saw in 1997, which is the top of the blue line, and the orange line is the most current El Nino. Dead ringers. So what I proposed as an academic exercise is actually now a real-world exercise. We just experienced an El Nino on par with the 1998 El Nino that we saw had induced the highest exposure across India. Okay? But we know that that exposure, if it were superimposed on today's population with today's reporting method, is unlikely to produce the 1,800 additional deaths that were reported in 1998. What would it produce? Well, if we use that mortality ratio, that factor of 3, we would take that 1,800, multiply it by 3, you get to about 5,000 to 6,000 additional deaths in expectation of this coming pre-monsoon season. Another way to do it, we know that the exposure the climatic exposure in 2015 was about half what the climatic exposure to heat waves in 1998 was, and yet the deaths were about 2,500. Take 2,500, double it, you're back at 5,000. So it's a conservative estimate that in this coming monsoon or pre-monsoon season, there's an expectation that the additional deaths will double what we saw last summer in a non-El Nino year. And so that is, in fact, the conclusion that we came to in this paper, that we now have this ability with what used to be a 3 to 4 month, but now is a 1 to 2 month period, in which to start to put into play all the adaptive and mitigative policies that we might need to prevent 5,000 to 6,000 additional deaths, and in fact put into play policies that might reduce that much below it if we can act quickly enough. And so that was the whole intent, was to make sure that people are aware, given the state of the equatorial Pacific the past winter, that in fact we're in for what could be a potentially much more staggering loss of life compared to last year. Okay? So I will stop there. The next sections, if you want them, are projections out into the future and following those trends. Just know that India, as far as heat waves go, are going to be at the mercy of climate change, more so than any other nation in the world over the next 100 years, would be the take-home message. And I think we'll wait for questions, but yes. So I will finish there. And I know there was one right here, so wait for the microphone.
Wait for the mic. It says we are webcasting.
Okay. Yeah, I was kind of wondering about the disparity in numbers, and you suggest that it's underreporting rather than. Could you just go over those factors again about the disparity in numbers between 2002 and 2015? You said underreporting was possibly one factor, and you also mentioned the possibility of a greater population growth in areas afflicted by climate change. The reason why I was thinking about it is, like, I lived on the east coast of India, and I was actually there to experience the heat wave in '98, and it was really bad. Crows and pigeons falling out of the sky dead and stuff like that, literally. And it was so bad for years after that. 40 degrees, 104 Fahrenheit in April was normal. Heat waves were a normal thing. But it really does make me somehow wonder about what really caused the last anomaly. It's like I'm not entirely sure if I've understood what caused the change in the numbers, this dramatic spike.
Well, physically, the expectation is that as you change the surface temperatures of the Pacific Ocean, you're changing the difference in temperatures between the ocean and the continent. And effectively, when you have warmer than normal temperatures, you do two things. You, A, delay the onset of the monsoon, so you can go deeper into summer, accumulating ever larger amounts of heat, longer heat waves, before you finally break. The other thing is that when you do have your monsoon, it's a much weaker monsoon than you normally would have. And so those two factors in combination. Now, as far as the relationship to mortality, yes, we were duly surprised to find that despite the fact that 1998, as you described, it was egregiously bad, had a mortality that was so substantially less than last year, where the exposure, at least to the climatic factors, was half of what it was in 1998. And again, we won't be able to parse out whether that's just because there are so many more people that are being exposed, or whether it's just that there was really poor reporting of what was producing that mortality. And we can't tease that out, but we can, through this method, say, well, were we exposed to, in the olden days of 2002, with both bad reporting and lower populations, that type of 2015 heat wave would have been reported to only have had 750 additional deaths. So that's the threefold factor that we've sort of come up with.
I also think that the heat waves are being reported as other deaths. It may not be attributable to heat, but it could be strokes, it could be so many other cardiac arrests, so many other things may be the factor that they are reporting under. Because they didn't sort of know that this is a big consequence of climate change.
So I actually was going to ask about that. So the sort of heat wave mortality, morbidity studies in the developed world the admissions data are notoriously suspect. So, people are recorded as dying of heart attacks, of all kinds of things, when in a sense the underlying proximate cause actually is the heat wave.
Oh, yeah.
But that's not what gets put on, so all these investigations basically have death certificates.
Right.
They're always underreporting. I mean, when you showed the table of reported deaths, I mean, there was 1 year on there that had 2.
Yeah.
Right.
Right, and so that's
You
just
can
not
see it on there.
sensible,
There's a few
right?
blue dots down there that sit on the
In a country of more than a
x-axis.
billion people,
people.
that they recorded 2 deaths from heat in whatever year it was. So how do you, I mean, that's a significant source of uncertainty in this estimation process. How do you think about that? How do you account for that?
So we sort of, Bruce, you can also add in because we had lots of discussions on this. And Susie sort of brought in another confusing factor, which is we always pay attention to the very young and the very old. And these kind of heat waves are impacting people in their 30s, men working out in the fields. And she had come up with all kinds of ideas of how to protect them. And that's one of the things that we don't think about, that we need to change the way we communicate. Even in the United States, we pay attention to the very young and the very old. And in India, this is the case, that there is underreporting of all other age groups because they're not paying attention to the heat.
So, just as a sort of a methodological for this thing in particular, the 2 things we had to lean on were A, despite the fact that it's very, almost assuredly underreported, it is systemically and systematically underreported. If we had looked at these dots and it was a big circle, then we'd throw up our hands and say there's no way we can infer any information. We know all those dots are wrong on the y-axis, at least their positions. But at least we can argue possibly, because they're so linear, that they're all wrong in the same way. The other key then is that we may have to assume that the 2015 deaths or mortality rates are at least much better estimates. Now, if we can peg the 2015 as a more accurate estimate and recognize that then with some systematic offset, we can then adjust everything through this mortality ratio, then we can scale all of them up. So it requires that you systematically...
So that raises a second question, right? So a characteristic of these kinds of studies, actually a characteristic of heat wave mortality phenomena in North America, to some extent in Europe, is that people actually do adapt. Cities adapt. So you have a high mortality event. Cities do things. They actually respond institutionally. And so you can subsequently have just as bad a meteorological event and get, half to less than half the mortality. Right? And so is there any evidence? Is there any evidence of that
Here's
happening
what's missing.
here?
Who dies from heat?
Yeah.
People who don't have air conditioning. Who doesn't have air conditioning? Poor people. Who doesn't go to the healthcare system when they're sick or dying? Poor people. So who's not captured in that is poor people who are probably dying way disproportionately. But since we don't have data on who died in terms of their age or socioeconomic or anything like that, this is just the people who somehow came to the notice of the health service or of some sort of official recognition of death, and it was clever enough to know that it was somehow heat related. But I'm guessing that the vast majority of people who died were poor people who didn't have air conditioning and who just never came to the attention of the health services. So this is probably, probably systematically a massive underestimate.
We say conservatively estimate.
These would be the more wealthy people that somehow got caught, their air conditioning broke down or whatever, or for whatever reason, or the elderly, or the very young. But we're missing a big part of the picture.
So if we can sort of build that association, so statistically we can build a model of deaths. And I've seen 1 or 2 papers that are suggestive of that.
Right. Yeah, I was really thinking the same thing that Tony was. I mean, if these were corals, then of course that's what Tony was thinking.
You'd actually get funded to do this study.
I don't know how to turn this on. It's on? If these were corals, we already know that there would be evolution in a very short time, and that with each successive heating anomaly, you would get, at the population level, a better adapted population. Of course, people can adapt behaviorally. My question is really, do you think it's possible to annotate the data sufficiently to look directly at and measure the adaptation effect? Because that's a very important component of any forecast.
So none of the studies that you showed earlier had any adaptation. I know all the studies. They
Right.
don't have any
No,
adaptation.
no, they don't. The
They impose
first,
the climate change on
Right.
today's world.
Right.
Well, that's not the way the world's going to unfold.
so this is the reason that the Lancet issue was very special, because they are for the first time suggesting things that are, have to be done in both in terms of adaptation and mitigation.
To get to your question about annotating the data, I don't think we have a long enough record to tease this out statistically. But if you could do a multivariate with some decorrelation time scale, you could you'd need a longer record. But you could find the year-to-year influences, and then you could find the lagged influences, and you'd expect so even if I were to plot out mortality, you'd expect after every peak to be a sharp drop. Yeah,
You know what?
a rebound down, a force down. And you might be able, with a longer time series, to pull that out. I don't think you're going to get it from here.
You know what I think you might be able to do, though? I was thinking about this as you were talking. It'd be possible to create like a misery days, people days of misery by
This is
the
close to it.
population times the number of days of extreme heat over a certain amount. And if you had the 98 number of millions of misery days, the population times the number of days, and then the 2015 or the 2010, I'm guessing that the ratio would be greater than 3. That in it might be more like 5, and the difference between 5 and 3 would be some indication of adaptation.
Yeah, and Susan, is it okay? Where's the boss?
Not until the microphone arrives.
Yeah, all right. It wasn't the mic I was worried about. It was getting. Yeah. All right. Yeah.
It's always on.
High tech expert here. One thing that struck me. I'm sorry I had to run out for another presentation, but one thing that struck me in all of this is that there's no indication of where the threshold or flashpoint is for war. If we learned anything from the Arab Spring, what I'm seeing now in northern Kenya and in Cambodia, that threshold is very low compared to the data that we're looking at. Is there any intelligent way to model that? No.
You have the microphone.
So you just have to suffer it when it happens.
No, so I'm going to interject, right, if you don't mind.
It's
There's
not
a
my
really,
wheelhouse, that's
there's
for
a
sure.
really long and really very weak literature on the relationship between climate and conflict.
Right.
Okay.
And it's mostly because there's no systematic way to identify what conflict actually is. Whether it's civil conflict, whether it's international conflict, whether it's just violence. Although there are a number of sort of independent databases on conflicts in the world, but they're all biased, right?
Yeah.
Because they're all systematically biased because in terms of reporting conflict, right? So they don't report, there's no data where there's no conflict. And so that automatically biases
anything.
every statistical analysis that's ever been done of it.
Right.
But I bet if you gave that question to a social scientist,
They'd come up with
they
an
would
answer.
tell you that it starts with graffiti on the walls.
Seriously?
Yeah.
Sure.
We're screwed.
It's about Muslim Bangladeshis go home, go back to your
Right.
country. We don't care if you're flooded.
That sounds
And
very familiar theme now.
very
Yes.
familiar. Go home, get out, et cetera, et cetera. And you can see these signs of conflict building before any blows have been exchanged. And I'm sure now you can probably see things on Twitter,
Right.
on Facebook, on all these other social media and so on. Because you remember, I don't know if you remember, you were there around that. I'm saying you're as old as me or approximately. When the militants took over the embassy in Tehran in '79.
That was just yesterday.
It was just yesterday. I know we were just young things then. There was, the embassy didn't have enough people that could read Farsi to know what was scrawled on the walls. And so they totally missed that this thing was building and building and building until one day, woohoo, we're all 400 prisoners or whatever they were. So there are signs that conflict is coming. But you have to be able to read them and then intervene. So I think social science has a role to play there.
Yeah, first of all, I think it's too bad that your health data are only at the level of all India. If you had even that state data, it would be so much better of a link between exposure and actual impacts. Oh, it's not on? Stop touching this thing. Second, I wondered whether you're familiar with the work of Brooke Anderson at Colorado State. Your graph here looks, she did this kind of work for cities in the US. And your graph of exposure versus health impacts looks very similar to what you see for the US, that there is a trend, and then there's a few high outliers. And she built statistical models for what the chances are for those high outliers, because each outlier basically has its own story of why it's that high. You know, it's either a huge power outage in Chicago during a heat wave, or any other reason, some other system breaking down, and that increases the death rate way more than you would expect just based on a normal relation. And it's also that any of those high outliers seems to be anecdotal in some sense, and so it seems speculative to just explain every high dot on these graphs. But saying what the chances are, what the risk is of a high mortality heat wave is another approach to this work, and would be worth looking into what she does.
Oh, I don't disagree at all. You could make the hypothesis that threefold jump, and it's a threefold jump, is something very unique to 2015 that hadn't occurred except for maybe in that other red dot that's over there. You're right, you could make that. We would have to go then tell that story and figure it out. There's nothing we can do given the... I don't think that story I don't think we can devise any experiment that's going to allow us with this data set to sort of do the counterfactual, unfortunately, is what it would require.
No, but we know the risk distribution of power failures in any particular country.
Oh, in India it fails every day.
We definitely know
365 days.
But you would have to go and find out whether 2015 was egregiously bad compared to any other to 2014. Because if you go back to the data,
You know that.
there's 2014 and there's 2015, and I would have to find the third highest dot in this thing. The third highest dot is, if I have to move, that one right there. So despite the higher, you'd have to, in any case, I would have to go and do it more systematically than that. But in any case, it does mean, 2014 is not on here, that's the problem. But it does mean that we would have to go and figure out why 2014, despite being hotter, wasn't showing up in world news, which 2015 was.
Right, so the other way to think about it, though, is the other anomalous dot, the one that's off the line
Yeah,
in terms
that's
of
the one.
mortality is whatever that one is that's up around 1,500.
Yeah, I'm trying to remember. We could go to the table and figure. I think it's 2003. At 2003.
Story associated with
Yeah,
that.
exactly. That would be a good way to start.
In any way similar. to
That would be
2000.
definitely a good way to start. You're
So
absolutely
I
right.
was just going to add, we haven't seen statistics for all other diseases and all other things happening. Malaria is very well documented in India. Dengue is very well documented.
wanna get back to-
AIDS is also documented. So heat waves is something that they don't consider because they have so many other things to take care of. Children dying, for diarrhea and waterborne infection is much more serious, I think, than looking at heat waves because a huge number of children are dying.
So I have a related question to that. Did you wait. I have a related question to that. Did you look at all-cause mortality or cardiovascular mortality? Something that is less ambiguous in how it's assessed, right, versus heat wave mortality? And
So-
did you follow the same trend?
So they do have information about some of the other mortalities on a detailed state-by-state level with some variations. They do collect a lot of data on malaria, that I'm very sure. They have pages and pages of malaria data because it's been well studied for the last 30 years or so. And we sort of stuck to the heat waves because of the temperature, the climate connection. We had all the data on climate. For malaria, we can sort of, use that data, connect it up with climate and study, but that's been well studied. So we picked a topic that's understudied, which is heat waves. And that's why we chose this. I hope it, so we had to use some logic on how to do it.
Right, so I would just suggest doing it again with cardiovascular,
Yeah,
because
okay.
that is very clearly associated with heat, and it's much better recorded than a heat.
Yeah.
So we'll be doing that, Patricia.
Well, it seems to me, a couple of things on these data. A lot of times, the way they determine the heat-related data is that they look at the anomalous increase in cardiovascular or other specific diseases. So I don't know exactly how, because I don't think when you go in and you die, they say this was specifically heat-related. They go in and say, all right, on this day, this many people died of cardiovascular diseases. That is much larger than we would expect at this time, but because of heat, we're going to attribute a certain level of those. And obviously, these things become even more complicated with the consistency across different stations and
right.
everything. I was just going to actually ask, I haven't had time yet to read, the World Health Organization just came out with the new Preventing Diseases Through Healthy Environments. And I'm just curious, in the 2006 report, they were attributing, I don't know, maybe 100,000 deaths or so a year to climate change. And I don't know if they actually covered climate in the most recent one, but if they did, what were they saying about India and how does this relate to the work that you've shown here?
So there are many, many studies, including the current Prime Minister's interest in, going all green and undertaking, and addressing climate change. But health-related stuff, Susie also noted, is, issue number 8 in his agenda. So unimportant. He's got like 2 lines associated with it. And of course, if you open up the plan, they have lots of things describing how they want to look at health, how they want to collect data, how they want to standardize across India, which is a huge problem. And they have all kinds of plans, but we haven't seen any scholarly work that's implemented that shows that somebody is doing something. But I do have to tell you that there are a number of people in India, very young college students who have their own blogs, who follow everything. They collect all the data and they are such fantastic blogs on India, on data. The one that I showed you for air pollution in India, it's someone's blog data. He's like monitoring on a daily basis all the different 60 different cities in India. So I think the youth will take over, and I think that's the reason I was emphasizing curriculum changes and making sure that climate change is sort of heard and public health is brought in, as a unit.
So I had a question actually, or just a comment on collecting the data. On death certificates, in the United States, you collect primary, secondary, tertiary. You can go down the causes of death. I'm assuming it's pretty similar probably in India. I'll give you, you think they just have one?
Urban and rural, there are differences.
Well, the interesting thing is, like, even here in the United States years ago, well, a number of decades ago, we didn't really collect information on elderly people with accidents. Like if they died from a pulmonary embolus because they were in hospital with a broken hip and were in bed, it was put into you got as far as the embolus, and then they had a DVT, and then that was due to the fact that they were in hospital with a broken hip. But just educating people and introducing it as a possible cause, I think really made a difference. Once that changed, and here in Massachusetts, it was within the past 15 years, then you saw that sudden spike in mortality in elderly people due to accidents in the home, like falling in the home. So I think introducing it as a possible cause of death to be recorded, I think would really help the data.
So that's one of the reasons we were all emphasizing that, there has to be education and outreach. And Susie keeps pointing out that there are these local communities with cultural, all kinds of norms that you have to take into consideration. And, I had one nice idea of building an app until she told me that she doesn't like apps. So then I'm trying to get her interested in my app because we want to design one.
Parking app.
Until there's a parking app, there is no others. One app to rule them all.
So I have an observation and a question. I mean, a lot of these sort of climate impact studies are sort of built around this notion, implicitly built around this notion of sort of gradual change, right? We do these average statistics and on declines in crop yield and increases in mortality and things like that. But it's not the way the world actually works, right? So the way this is actually expressed is as a series of events.
Yeah.
And so in some sense, what you really want to look at is not just this sort of statistically average rate, but what's the jump, what's the anomaly, right? What's the jump in mortality following events of particular sizes, right? And so is there a pattern in the anomalies? Now, you sort of have that here, but you certainly have the data for it. And the reason I emphasize that is that you could do an analogous thing, I think, with floods, right? And then you could actually structure a comparative study of, sort of what's the jump in mortality from all causes or just water-related causes in the 3 months after a major flood for the affected population. What's the jump in mortality of heat waves in the affected population? And you could extend that time period out so that you actually start to capture the vector-borne diseases, particularly for floods, that start to occur with a lag time after the breakdown of all these water management systems. That might be a sort of a unique and really interesting way of looking at the data.
If we can get the denominator. 'Cause that's kind of what we're missing now, but I don't think it'd be too impossible to get at least an approximation of how many people live in that area that just
Yeah.
flooded.
Right.
So, you know.
Right. Yeah, and then, because you could probably get that from national, or some estimate of it, either from national
Estimate,
census
yeah.
data or from something like
Generally,
Landscan.
you have fairly granular data on population density.
Or from something like Landscan, which
Yeah.
is at least imputed population, the spatial distribution of population
Yeah.
densities.
Having worked with some of this data, though, I think the catch will be your statement, extend it out in time.
Well,
None of this,
You
as
can
far
only
as
do-
I
you
can
can
tell
only
through
do
these,
what you can do,
yeah,
right?
as
So-
far as I can tell, you'll see that data ended in 2008. In 2012 is
It's very
when
spotty.
they actually made a countrywide systematic effort to improve their reporting on mortality. So if you plot these deaths through the last cycle, what you'll see is, however you would see it, you'd see a line and then you'd see this step jump. So really the only good data at the state level within India so that you could break out geographically
2012.
since 2012, yeah. And that's the hardest part.
You can only do what you can do. I mean,
Oh, yeah,
if
no,
there's
that's-
patterns in the national data before that,
Yeah, that's
that's
exactly what we were after
worth
here.
some look, right?
Oh, yeah.
And there's also, data sharing and dissemination of data is not very common in terms of health
Right.
data. All the census data even is owned by private companies. You have to pay money to buy even census data. And that's what Michelle found out.
Yeah, oh, yeah, no, it was
I was asking
socioeconomic
somebody,
data at
what
the
data
tables.
can I buy? It's census data of India.
Somebody else who hasn't gone. Anybody else? No, all right. Sorry.
Last word, Les.
Yeah, seems to be like cottage industry. So one of the things I've noticed in the last few years in a couple of places, Fiji in particular, is that in coastal areas there's a synergy between heat anomalies, thermal anomalies, and violent storms. And that's because heat generates storms and makes them worse. So like in Fiji, there was Hurricane Winston or Typhoon Winston, and now suddenly there's a massive flood, and both of those were preceded by an extreme heating event and mass bleaching of coral. Ironically, the marine side is coming out sort of okay, but there's absolute devastation in the vegetation communities of Viti Levu now. So one of the things that might be worth looking at is not just a lag analysis, but also a sort of synergy analysis of climate-related events of all sorts.
Knock-on effects.
So I'm going to ask you my last quiz question. So which part of India is most vulnerable to climate change, based on all what you've heard? Okay. So I think you're right, because the population density is highest around the Ganges plain, so obviously. But increasingly, the southern part of India, the two coasts, especially the state of Gujarat, where the Prime Minister comes from, has also experienced a lot of heat waves. And so that's why he became a climate change. The book he wrote was like Al Gore's book, lots of pictures. If anybody wants to see it, Tony has it upstairs with lots of pictures. Really nicely done. So, it shows that all of India, in my estimation, every part of India is vulnerable for something or other.
So you're saying it was a trick question?
Great.